Hello. In this video, we're going to use the tangent lines that we find from doing our derivatives in order to approximate nearby values on a given curve. So I have some function f of x, y equals f of x, and if I look at the point a comma f of a, the derivative at that point, f prime of a, is the same as the slope of the tangent line. So if I draw an example of this on my coordinate plane over here, at this point a comma f of a, we're able to draw our tangent line like so, and that tangent line has a slope of f prime of a, whatever the derivative of that is, at the point A. So how do we write the equation for that tangent line? Well, we typically use our point slope form, and so we'll say y minus y1 equals m times x minus x1. Or rather, if I start plugging in the points, there's an x1, there's y1, and here's my slope. So I'll have y minus f of a equals, the slope is f prime of a, times the quantity x minus a. And what I'm actually going to do here is get a by itself, so I'll read it as y equals, and I'll say f of a plus f prime of a times x minus a. So that's my equation with y by itself, and we can use that equation to approximate nearby values. And so to draw an example of this, if I were to zoom in on my function, so I'm going to zoom in on this point, and so down here is where I'll draw it. If I zoom in on this even further, we're basically seeing this tangent line getting drawn at our a comma f of a. So what this does for us is that if we wanted to find some value here at b comma f of b, we could find or we could approximate what that value f of b is when given what b is. So suppose that instead of a comma f of a, I knew that this point was, let's say, 2 comma 4, and that f prime of 2 we could find to be 1/3. Now I can approximate what my value is at 3 using this equation over here. And so my new y value is going to equal my f of a is right here, it's 4, plus the slope is 1/3 times my new x value is 3, we want to go toward 3, minus the 2. So evaluating this, we're going to come up with y is 4 plus 1/3 times 1, or y is equal to 4 plus 1/3, or rather y is equal to 4 and 1/3. So we're saying that our new point is at 3 comma 4 and 1/3. Now obviously we can see that it's not at 4 and 1/3 because we're referring to the line. Right there, that would be 3 comma 4 and 1/3, but we're pretty close to it, aren't we? So maybe we shouldn't say that it's exactly that, but we should approximate it. And so what we're doing is called linear approximation. And it takes this equation right here, that's poorly drawn, there we go, this equation right here, And instead of y, I'll use a function L of x. So it's the linear approximation at x. But it's going to be the exact same thing. So I do whatever f of a is plus my slope times x minus a. So it requires knowing an ordered pair and the slope of the tangent line at that point, and that allows us to make an approximation for all the y values at points near that a value. Okay? And so it's this equation that we will be using in class tomorrow. We are done.